Today's lesson is about exponential equations. Example of an exponential equation is when the variable is in the exponent. For example, 2 raised to the power x is equal to 2 to the 5th. So because the variable is in the exponent, it's called an exponential equation. Of course, equation requires the equal sign. So the variable in the exponent and the equal sign, so together you get an exponential equation. So today we want to solve these exponential equations. So the best way to solve these is by using logs, but we're not going to cover logs in this equation. So and if you remember log, for example, log base 2 of 2 is equal to 1 because we could change it to exponential as in 2 raised to the 2 to the power 1 is equal to 2, right? So this here is the base, and this is the exponent. But we're not going to use this idea of log to solve this. We're going to use one strict rule. And the rule we're going to use to solve this is this one. If, for example, here we have this equation. So let's think about this for a second. If 2 to the x is equal to 2 to the 5th, and they are to be equal, right? They must be equal. So x could only be 5, right? So let's think about it. Can x be any other number but 5? Because they have to be equal, right? So if x is any other number than 5, they won't be the same. So the process we're going to use is that if the base are the same, then the exponent must be the same for them to be equal. So we're going to use that instead of using log. So we're not going to use log to solve these exponential equations. We're just going to use the fact that if the base are the same, or you could take log of both sides of base 2, because that's equal to 1, so it's going to bring everything down. Right? So if I take log base 2 of both sides, then you just get x equals to 5. But we're not going to use log. This is the last time mentioning log. We're just going to say if the base are the same, which in this case the base are the 2's, if they are the same, then the exponent has to be equal. So for example, let's solve this exponential equation over here. 2 raised to the power x equals to 8. Well, currently the base here is 8, and the base here is 2. So the bases are not the same. So if we're going to solve it with the idea that the bases are to be the same, then we have to change either 2 to base 8 or 8 to base 2. Well, it's easier to change 8 to base 2. All right, so let's rewrite the equation here. 2 to the x is equal to 8. We want to rewrite 8. So what does 8 equals to? Well, 8, you can break it down into product of primes, right? By just keep dividing, find any two numbers that multiply to give you 8, for example, 4 and 2. And then if you go further, 4 is 2 times 2. So then 8 is going to be 2 times 2 times 2, right? Which is going to be 2 repeats itself 3 times. So therefore, 8 is the same as 2 to the 3rd power. So now we get the base to be the same. So what we just did, we turn 8, we rewrite 8 such that the base is 2. So now that the base are the same, so then the exponents must be equal. So if 2 to the x is equal to 2 to the 3rd, then x must equal to 3, right? So that's the process we're going to use to solve these exponential equations. We're going to rewrite the equation such that they both have the same base, and then we just set the exponent equal to each other, right? So that's the process. So let's try an example. So example 1 here says solve 2 raised to the power x plus 1, which is equal to 16. So now we have to change the base 16 to base 2 because they must have the same base. So 16, how can we rewrite 16? Well, you break 16 up into any two numbers you like, right? Any two. So for example, 2 times 8 is 16. Well, 2 is a prime number, so you cannot break 2 down any further. But 8 is a composite number, so there are two numbers that multiply to give you 8. That's not 8. So in this case, you get 2 and 4. And 4 becomes 2 and 2. So 16 is 2 times itself 4 times, which you can write as 2 to the 4th power. So if we rewrite the equation, then we have 2 raised to the x plus 1, and that's equal to 2 raised to the 4th power. And so we use the idea again that if the bases are the same, then the exponent should be equal. So that means x plus 1 must equal to 4. And then we can solve this linear equation by subtracting 1 on both sides. And so this would say that x is equal to 3. So the solution for this exponential equation is 3. All right, let's try another one. So now we have, we want to solve 3 raised to the power 2x minus 1 equals to 27. So it's 27, we now have to change to base 3. So you take 27 and you break 27 up into its prime factors, right? So for example, 27, find any two numbers that multiply to give you 27. So you could say 9 and 3. So 3 is a prime number, so you cannot break 3 down, but 9 you can to get 3 and 3. So 27 is the same as 3 times 3 times 3, and that's 3 to the 3rd power. So if you rewrite the equation, then it becomes 3 to the 2x minus 1 is equal to 3 to the 3rd power. So now we argue again that the bases are the same. So the exponent has to be equal. So we're going to set the exponent equal to each other. And so you get 2x minus 1 is equal to 3. So now we will solve this linear equation by adding 1, which would say that 2x is equal to 4. Divide by 2, and that would tell us that x is equal to 2. So 2 is the solution for this exponential equation. All right, so we continue another example. Same idea, we need same base, and we set the exponent equal. So example 3 says solve 4 raised to the power x minus 1 is equal to 4 raised to the power 3x minus 7. So this one is not bad because the exponents already, the base are already the same. So we don't have to do any conversion. We probably can change base 4 into base 2, but that wouldn't help us anyway. Right? So let's take it here. Once the base are the same, it doesn't matter. We just set them equal to each other. So x minus 1 is equal to 3x minus 7 because the bases are the same. So we're solving this. So if we now subtract x on both sides, we're moving the smaller x term. You always do that to keep your x positive. So this would say negative 1 is equal to 2x minus 7. So now you add 7, So what you have is 2x is equal to 6, right? Negative 1 plus 7 is 6. So now you divide both sides by 2, and this will say then 3 is equal to x, or x is equal to 3 if you write it that way. So the solution for this equation is that x is equal to 3. All right, one more. And this one is solve 3 raised to the power x plus 5 is equal to 9 to the x. Process is the same. We need same base. So now this one has a x, but we're just going to change the 9. And don't forget your rule of exponents because we're going to need it here as well. But first, we're going to take the 9 and write it as base 3. So 9 is 3 times 3. So 9 is 3 squared. All right. So therefore, let's rewrite the equation, but we're going to remove the 9 and put 3 squared. So that means you get 3x to the 5th power. And I remove the 9 and put 3 squared. But remember, the 9 is being raised to the x power. Right? So it's 3 squared raised to the x power. Now, to simplify this equation further, you have to remember the rule of exponent that says if you have x to the n raised to the m power, then you have to multiply the exponent. So here I'm going to multiply the 2 times the x, right? Because that's the rule of exponent. So by doing that, what I get is 3 raised to the 3 plus 5 is equal to 3 raised to the 2x. Now we get the bases to be the same, so now we just set the exponent equals to each other. And so x plus 5 is equal to 2x. And we'll solve this equation by subtracting x on both sides. And what we get is that 5 is equal to x. So the solution for this equation is that x is equal to 5. So, double check to see. All right, so here, what I have next is some examples for you to solve using the same method. You want to have the same base, and then once you have the same base, I set the exponents equal to each other.